Hello everyone, welcome to this next question on complex analysis. This question is taken from the paper of 2010 and in this question they are asking what is the value of I given the integral over C, where what is the C? C is the curve mod Z is equal to 3, which is oriented in anti-clockwise direction. So here our curve is basically this one, having center at the point 0 and its radius is equal to 3. So our region of interest is this one, the shaded region inside this circle C, right? So this is the region. So in order to calculate what is the integral I over the C, where what is this? This is fz divided by z minus 1 and z minus 2. So first of all we must determine its pole or singularities. So in order to calculate these, we should substitute the values in the denominator equal to 0. So from here we had z is equal to 1 and z is equal to 2 as simple poles. Simple pole means the order of these poles that is equal to 1. Moreover, this function fz that do not create any problem because this does not become infinity at any point because the function sine and cos they are bounded functions. So here in order to calculate this I, what we have to do, we have to use this residue theorem, which says that if you have some curve fz which is analytic inside and on a simple curve C, then we would say except a finite number of points. In our case the points are z is equal to 1 and z is equal to 2. So what we do, we just calculate the residue of the given function at those points and then we add up those and then multiply that by 2 pi iota. So that would be our integral. So and how do we calculate these residues? So these corresponding residues are calculated using this formula where what is m? M is the order of that particular pole and a is that particular pole. So let us get started. So here our I is given to be integral over C of the function sine pi z divided by 2 plus cos pi z divided by 2 divided by z minus 1 into z minus 2. So that would simply be equal to 2 pi iota multiplied by the residue of the function fz calculated at the point z is equal to 1 because 1 is the simple pole, and then the residue of the function f of z calculated at the point 2. And what is f of z? F of z is this whole function. So this whole term, this is our f of z. So let us calculate this. So we would have 2 pi iota. In order to calculate residue at the point z is equal to 1, we have the value of m is equal to 1 here, right? So this term is 1. The derivative, we would have 0th order derivative, so that would be meaningless. So it would simply be limit z goes to 1 and then z minus 1 raised to power 1 multiplied by this f of z. So it would be sine pi z by 2 plus cos pi z by 2 divided by z minus 1 into z minus 2. So from here this term and this term cancels and the residue calculated at this point would simply be limit z goes to 2, the value z minus 2 and then this function f of z, that means sine pi z by 2 plus cos pi z by 2 divided by z minus 1 into z minus 2. So from here this and this cancels. So let us substitute the limits. So we would have 2 pi iota multiplied by, here when you substitute z is equal to 1, you will be having sine pi by 2 plus cos pi by 2 divided by, here you would have 1 minus 2, that would be minus 1. And similarly in the second case you would have, when you substitute z is equal to 2 into this equation, you would have sine pi plus cos pi divided by 2 minus 1, so that would simply be 1. So we all know what is the value of sine pi by 2. it is equal to 1, and the value of cos pi by 2, it is 0. So this term, and the value at sin pi, that is 0, and the value at cos pi, that is minus 1. So it would simply be 2 pi iota, and here it would be minus 1 and minus 1, so minus 2. So that would simply be minus 4 pi iota. So this is the value that we obtained for this integral I. So let us look at our options. So from here, option D comes out to be the correct option. So well guys, that is it for this video. I'll see you in the next one.